record.
Hi, everyone. Today we have something really special. The world's first independent attempt at the Hutchinson effect. The replication of it was tried a couple nights ago, and what it was Bob Greenyer came over to Canada to meet with Carmen, and Ryan was there as well as Rob Harris, and Rob Harris is the inventor of Therify. So they had a great meeting at Carmen's. They did a little bit of a YouTube, which is fantastic, talking about Carmen's father's magnet motor, which is like it, it it's a motor generator at the same time. And then a couple of days later, they went to Rob Harris's place in BC still, and attempted this experiment, and I didn't know that John Hutchison was actually going to be in the live chat, but he was. So we're going to go through um, some of the screenshots that I took of John, and some of the stuff I'll be able to comment on, and some I won't because I was kind of listening and taking screenshots at the same time. But I'd also like to thank Chris Beskar for the information that we're going to do about Ken Shoulders later, and I also want to send this to Chris. So thank you. And again, this is the first independent attempt at the Hutchinson effect outside of laboratories, probably military laboratories out there. So yeah, so this is the actual YouTube. There was a really long one where the screenshots are. I think it was 4.75 hours long, and then there's a shorter version that talks about the setup, which is about 15 minutes long. And then there is another one where they are talking about Carmen's father's device. So they're all fantastic. So we'll just kind of go through these. And I'm probably going to have to get close up here to read with my glasses. But so this was the actual experiment. I just took a screenshot of it. And you can go on to the next one, Brandon.
Next
We'll,
one is Hutchinson and Hutch photo.
yeah, exactly. So I brought this one in again. I've showed this picture before a few times, and this is a picture of John Hutchison with the hat and his good friend Ken Shoulders. And in you'll see in the screenshots that John actually talks about Ken. So these guys they were great friends, and these two men, other than Chris Beskar and maybe a few other people, there's probably no one on the planet that knows more about charge clusters or knew more about charge clusters, because Ken's research is essentially everything that we're going through. I have to thank Chris Beskar again for giving me all of Ken's patents and all of his research in a big file that he sent me. And that's actually the stuff that we're going to be going through even today. And we've gone through it in the last couple of shows. So yeah, these guys were the best of friends. And it is all about charge clusters. So we can go on to the next one.
See, so that would be John Hutchinson number one.
Yep.
Hey Ed, can I ask questions in this format?
Oh yeah, absolutely.
Okay. All right.
Absolutely. I'm just going to have to make this bigger so I can see it. So again, yeah, let's just start there. I just need to see what it says here.
Um,
You're gonna make it bigger?
this is I'll make it bigger.
Okay, cool. This is about the point where I realized that we actually had John Hutchison live. I was actually a little bit shocked. So somebody was asking him some questions, and he said mass and RF fields plus others. So basically, he's talking about the setup for the experiment here. We can go on to the next one. I don't think there was any other Hutchison effect on there. That Hutchison effect is John Hutchison himself.
Oh, okay.
So it appears to be a Tesla globe there.
Yeah, there was. Yep, there was. There was a whole bunch of stuff set up there. There was 8 Therify bulbs set up with 2 controllers. You can see the controllers that are behind the blast shield there, where that red I think that red thing is a variac, probably making sure the voltage is just perfect for all of that. This was fantastic. No, I don't know um, if they actually had any success. Oh, there's a few more there. Just I have an interest in old Navy stuff and Teslas. So a lot of people don't know that John Hutchinson lived in Vancouver back when I first found out about him, and of course Carmen has known him for probably 50 years or something. But he lived in Vancouver, and what he did is he took old Navy um, ships apart. So he was actually taking all the electronics out and bringing them home. Is what he did actually. And I can remember at one point he had a 1,000 pound Siemens X-ray transformer, and I could just imagine, that's like having a waterbed on your floor. And he lived in an apartment at the time. So so he was taking Navy ships apart, like Gordon novels. I don't know what he's talking about there. We can go on to the next one. Um, like I said, I kind of jumped in and I was taking screenshots as I was listening to the experiments and whatnot.
This one here.
Yeah, whatever the next one is, because all of them have a little bit of John talking, and I just wanted to kind of show these to you guys because it's kind of really special to have him. So that's the same one. I think there's something at the bottom of that one that probably has him as well.
So, Ed, could you provide a little background on this? Did he stumble into this, or he actually working with Ken Shoulders, and he put a framework together to specifically investigate charge clusters and that kind of stuff? Or did he
John
kind of luck into it?
John Hutchison. See, Bob Greener's actually writing a book about John,
Yeah.
and that's why there's such a close connection between the two guys, right? I guess there wasn't another one on there. You can go on to the next one, Brendan. So what I know about John is the military approached him at some point, and after that part, nobody kind of knows what happened really. I guess it'll probably be in the book, but my best guesstimate is John went to work for DARPA at that point, and or at least was connected with DARPA, because you'll see in here where John actually says that he sent this link to his DOD friend, so his Department of Defense friend, and I had intuition that he was actually on the call with us, the DOD guy.
Your technology
have
envoy. That's you, Eddie.
yeah,
Technology envoy.
yeah. So John's just talking about a transformer here. I said, John, I know Ken Shoulders' business partner, Chris Beskar, the CEO of Stevati Aerospace, and I'm very grateful for all your contributions. John's just talking about a Google search. Oh, that's the ship. That might have been one of the ships that he was working on. It's HMCS. That's a designation for military Navy destroyers. So it might have been, I think that might say the Yukon, I'm not sure, and Columbia. So those might be two ships that he actually worked on. We can go on to the next one. We'll just go through these ones fast because I just wanted to kind of show you guys that he was there and kind of what he was saying and whatnot.
It looks like most all of his work started about 1979, late 70s.
Yeah, that's about, see, I learned about John in 1980. So he probably was in, I'm not exactly sure when they approached him, because at one point he ended up getting all his stuff taken away, and then he went to Germany. And we'd have to ask Carmen. Carmen would know the exact timing of everything. So here's John. Yeah, so and Google search HMSCS Yukon and Columbia. So I'm pretty sure those are Navy destroyers. See my 1989 footage, he's saying. So he's got footage out there where he levitates a 12-pound cannonball. He levitates. There's a cool shot where there's a plastic cup with water in it, and the actual water levitates before the cup does. So that's a cool one. He levitates all kinds of stuff, and you guys can go on and check out his. There are some websites, and they're actually in here as well.
Can I
So
go for a
that's
quick
another.
look for them? Do you want me to have a quick look at them?
No, 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 no,
No,
no,
no.
no,
Okay,
no, no,
okay.
no, no, no. Let's just carry on because we have a lot of stuff to go through here. So let's go on to the next one. But I think he lists the websites in here, or links, or not links to them, but he references some of the stuff here, and that's also why I wanted to go through this and record it. So this one, John, is okay. He's talking about Dr. Macrosky in Quebec. John, where did you find where the info Tesla's doing in Quebec? So he's actually talking about who he got the information from, which is something that a person could probably have a look at later. HMC, yeah, Yukon, yeah, those are definitely shipped. Okay, so we've gone to the next one. Like I said, I didn't really look at these. I just picked out the ones that had something from John on them, and I just wanted to kind of go through and comment as we go along because there is some really good stuff here. And this one, so he's talking about Jack here and just answering some questions. So again,
And how
I
recent
wasn't,
was this, Eddie? When was this roughly?
this was on Thursday night. Very late, late Thursday night. Study Dr. How do you pronounce that?
10 shoulders, maybe?
No, Dr. R. You see it? Yeah.
Rauscher,
Dr. Rus Ruska.
Rauscher.
Rusher,
Rauscher.
Yeah.
Ken Shoulders, Harold Wilson,
Wilson,
Bob
Bob
Greenyer,
Greener.
plus
Yeah.
many more. So he's talking about who's got the scoop on his research, essentially, where to look. And of course, Ken Shoulders' name comes up. That doctor I did not know about. I'm going to have to check into that and dive in it a little bit more. Yeah, so we can go on to the next one. It's kind of good because this is being recorded, so people, if they want to do more research on John, they can actually go back and look into some of these other people that he talks about. And that's kind of why I was taking the screenshots, because he was talking about stuff that I've never heard about. Yeah, so there's that. I think there might be one at the bottom of that. Latest stuff is beyond metal softening. So he was there at this point. They were talking about how the metals got softened, and I don't know what he means by latest stuff exactly. Nancy is filming it all. Nancy is John's wife, so she's got they were there. Yeah, it was really really special. Definitely. I think we can go on to the next one. I think he might talk a little bit more about this metal softening. I think somebody was asking him questions. And what do we got? Great photos. No glass chambers. I don't know. I don't know what he's talking about here. I met a scientist who knew their stuff. Interesting. Bob is getting things out there, which he definitely is. I mean, that's why we're watching this and doing this, is because of Bob actually coming over. Because Bob came over to visit Carmen, but they had all this set up with Rob Harris before, but I didn't know about. Bob Greenyer is studying the non-linearity. That is really, really, really important to everything. I think we can go on to the next one.
Nonlinearity is secret to so much of this
Yeah,
hyperdimensional physics. Yeah.
yeah, exactly. Bingo. Yeah, it is like the most important. Big help. AI. I'm not sure what he was saying there again.
Big rise in the oil spill.
and I want to give a successful demo. Not sure if he's talking about this one or perhaps something that we have planned for next time that I'm really happy to talk about here in a little bit. Demo sounds very exciting.
Longtime DoD friends. I would have expected he would have demoed it to them already in those early years.
He definitely would have. The DoD friend thing was that DoD friend was sent this so that he could watch it.
Oh, I see.
Yeah. So yeah, I want to give a successful demo to long time DoD friends, and he had done that. I think it's just that this
So
is the first
DOD
time
is the military, is it DOD?
Department of Defense.
Yep.
Yeah. So more than likely, he's talking about his DARPA friends.
Yeah.
Um, I have no doubt. And it's interesting. I was thinking about this morning that isn't this interesting that the first time that it's ever been replicated in public is right after Trump gets in, essentially. So there's some timing in all of this as well, too. In fact, they're letting John release this stuff and let them go through all of this. So I think if there's nothing at the bottom of that one, because he does talk about the DoD stuff. Yeah, DoD friends. Okay, so there's none in that one. And this one, what has he got to say here? So my intuition chip told me that the DoD friends were watching and they were on the call, without a doubt.
Yeah.
Oh, this is the same one. Maybe I copied the same one in. Yeah, because we just saw that. Let's see if there's something at the bottom. Oh, there you go. With the help of great folks like um I'm not sure what's behind the heart and other.
You and others, maybe. I don't know.
Yeah. See, the DoD is watching us, guys. See? So maybe that's even the DoD guy or somebody that knows who the DoD guys are. But I had a sense that they were there, definitely watching this. They're basically letting this happen, is what's going on. So again, it was
Yeah.
really kind of special to be there. Like I said, I didn't expect John to be part of it. I was really, really thrilled when I actually saw him starting to do comments. And at first I was like, John who? And then I realized, excuse me, that it was John Hutchinson himself personally.
Did he have his patents sequestered under national security acts in the United States?
Ooh, boy. No, that's a question for Bob Grenier.
Yes. He'll be
Only be,
looking into that for the book. Yeah.
yeah, exactly. Bob knows most all. You know who else would probably know is Carmen. I was actually hoping that she might be here this morning, but she would
Yeah.
she would also know.
Yeah,
'Cause
that's exciting. We're working with Trump in the background on a separate loop on releasing those 6,300 some
Yep,
national security order patents that have been held for,
yep,
God, some of them 80 years.
yeah, exactly. And likely, like you said, some of them are definitely his. They're the Ken Shoulders patents, interestingly enough, I don't think are in that group because I've got all of the Ken Shoulders patents.
Yeah.
So Chris wouldn't have been able to give them to me had they been in that group. So that's kind of interesting. Let's see what's on the next one here. Um, what has he got to say now? Let's help great folks. I used hundreds of pounds of junk.
Used. Oh, I used, not fused. Yeah.
Yeah, I use hundreds of pounds of junk sold on eBay, um, and gifted to congressmen.
Oh, interesting.
How nice of the Department of Defense to hang out with us and gifted to congressmen. So obviously there's a lot of friends. There's lots of people watching this, essentially, is what he's trying to convey there. I, Pentagon people, undoubtedly, because that's who his friends were, essentially. They saw the genius in him. John I don't know, but this might be in the book. My understanding is John could have been part of Star Wars or SDI, Strategic Defense Initiative,
Yeah.
with Ronald Reagan, right? Um, I guess it'll all be in the book, or we can again ask Bob Grenier or Carmen. Carmen would probably know again. So yeah, let's see what's on the next one. So you can see by those last statements that this was obviously all set up so that everyone could watch and be part of, including congressmen. So that's interesting too.
I see the Therapy bulb there.
Yeah, yeah, they had 8 of them going, and of course, it was Rob Harris. So Friends. Is there anything at the bottom of that one?
So the Therapy bulbs ultimately produced or
The,
attempt to produce a longitudinal waveform.
oh yeah, the DoD is going to be ringing the hotline to the Navy. John, have you met Canadian? Oh, okay, who worked on a lot of these things. So he's talking about another person that's done some research. That's why this is so awesome, because we're seeing people that I didn't know about. That's for sure.
Coming out of the
Com
woodwork. Yeah.
yeah, coming out of the woodwork, exactly right. Yeah, well,
Yeah.
let's check out the next one.
So when was this done? This is a very recent YouTube, right?
We did this live Thursday night,
Oh my gosh, yeah.
and that's why like I was saying, I stayed up till 4 in the morning, and then we met on Friday night, and I was gonna tell you about it, but I didn't get a chance to. So I'm
Yeah.
glad you're here to see this. So
Yeah,
um
I'm trying to conflate everything that Sal Paez has patents on and everything, all the stuff with electrogravitics. I mean,
yeah,
that's essentially an umbrella topic for the very specific things John was doing with this
yeah.
gigantic amounts of voltage here.
So right here, I shared this with my DoD friends already. So basically, he's saying that his DoD friends are on here with us. Essentially, is what he's saying. Um, which was, yeah, a lot of the other people were talking. So, John, when the knife sunk in the softened aluminum in one of your experiments, does the aluminum solidify immediately when the effect got, or I'm not sure what that says,
Goes away,
The
yeah.
effect something
goes away?
goes away,
Yeah,
or does it
or
take
did
a
it
little
take a
time?
little time? And then he answers, I think, from what I remember.
We'll go to the next one.
Yeah, let's
Yes.
check out the next one and see what he has to say. Because there's one where he sinks a butter knife into the aluminum, and I think he did that while it was still in its molten state.
Wow.
I'm not going to say hot because I don't think it's actually hot. Is there one below that one? Oh, right there. I'm supposed to be there this
Xmas,
Xmas
Christmas.
this Christmas. Okay. Um,
He's answering a previous.
yeah, and yes, turn solid. So I think
Wow.
yeah, right. So I think he sunk it in and then it turned solid.
So
Is
what is it about the spin and charge clustering effect that is self-correcting? That's interesting because it's going back, the transmutation process is reversing.
Yeah.
And,
Yeah,
and so,
this is all about black holes and white holes and the transmutation process. There's stuff going on here that even we probably don't know exactly about, and that's why they're bringing all this out and showing us to the public, right? This is like the Hutchinson effect is actually super, super special and very, very real. Like a lot of people don't think it's real. Well, it's real, and that's why we're going through all of this. We can probably go on to the next one. I don't remember the glass tubes from before. I think they were talking about these glass tubes, and some of them had different gases in them. And Paul Harris would walk up and sort of wave them around to see if there was anything going on with the fields and whatnot. I shared with DoD friends. I'm supposed to be there. Yes, turn solid. Someone says DoD. What glass tube? So okay, that's what he was referring to, was this tube that Paul had in his hands. We can go on to the next one.
That's it. So that's number
Okay.
one. Hutchinson number one. Do you want Hutchinson number two now?
Yeah, let's jump into number two. And I do want to tell you guys about something that's really special. So when I found out about Carmen's conference next summer in Penticton and knew that Bob Greenyer was going to be coming and she invited me to come, I asked Carmen at one point, I said, it'd be awesome if John Hutchison could come. And Carmen said, yeah, Bob Greenyer would have to bring John from Germany. So, and unfortunately, Carmen missed this because she was on the call and then she left. And like I said, it was 3 and 4 in the morning. But there's a spot in the recording where John is asked by Bob Greenyer to come over next summer to this conference of Carmen's, essentially. And I believe they might actually do another one of these experiments. So that was really, really special. So he's saying, yeah, what glass tube? Okay, Krypton tube off Navy ships.
And I think
Gamma,
it's argon. I think it's argon in the verified bones.
yeah, yeah,
Very inert gas. Yeah.
yeah. But they had other bulbs there though too. They had bulbs that had different gases in them. There were long tubes that Paul Harris was waving around to see if there was any interaction with the field. But the off-Navy ships, I'm not exactly sure what he's talking about, but that's really important because that's where all of his stuff came from. And this is really cool. Elon is watching because Elon knew something we are discovering. So someone's saying Elon is watching this, and then watch this. This is really funny. But you can go on to the next one, where John has a comment about that. And I wouldn't be surprised if Elon is watching this actually, or is going to watch this, because the Hutchinson effect is so important to science. It's unbelievable. It's an
Yeah, I
interesting.
got the book for Christmas.
There's 111 people. So who is Elon?
No, that's a good one.
That was awesome. We're all laughing our heads off when he said that.
Wow, Sparky's still going. Floyd Sweet's not still going. Obviously, he died in 1996, but
Yeah, yeah. So we can go on to the next one. Yeah, that was a priceless moment. Who is Elon?
yeah, he's being facetious.
Exactly right. I wouldn't, I wouldn't be surprised maybe if Elon has contact with him, even perhaps,
Yes.
because again, this science is it's the pinnacle of science on the planet at this point. Charge clusters, and John and Ken Shoulders are the geniuses essentially that did all the main research with it all.
Oh my God, I just dropped dope fire.
Exactly.
Yeah, I love it. Yeah.
See, it was awesome. We're having a great time. Yeah, I'm going to the next one.
Uranium Bowl, singing Uranium Bowl. That's interesting.
They had all kinds of stuff on that table. And you know what? The experiment carried on, so I don't know if there was anything to be seen or not. And we might quiz Carmen when we have a chance, because I'm not sure Carmen might have been here. I didn't ask her, but no, she wouldn't have been because she was on the chat. Yeah. I got funded for my power cells by different clients. So at one point, I'll never forget this. John, he lived in Vancouver. He lived in this apartment building. He went out, and this was filmed. I saw this. He went out into the alley and he found some what looked just like normal rocks, river rocks. They're quite rounded and whatnot. And he stuck them in this container that had some electronics on it, tightened it up. And this is known as the rock battery. And I think that is what he's referring to there with power cells. It may or may not be, but I do know that the Japanese bought his patents out for the rock battery. And he was able to
Just
produce
any old rocks? Were they just any old rocks?
It seemed like it. I mean, they might have been a specific kind, but he just randomly went into the alley and grabbed a bunch of rocks and threw it in this thing and tightened it up and turned it on, and it worked, and it produced 0.7 volts, I think, if I remember correctly. That was
Wow.
going back to the 80s, actually. That's how far back that goes. Yes.
You remember that back in the day, the Chinese were mining jade boulders out of the Snoqualmie and Tulameen rivers in BC.
Yep.
And I could see him grabbing a chunk of aluminum silicate, as in jade and various other combinations thereof. And that might really be interesting because aluminum does really weird things in these kind of fields. And the silicates, obviously, you add silicon to the picture, and now you got all kinds of
Yes.
hexagonal, tetragonal resonances created. So
Yeah,
I was thinking
exactly.
the rocks might be a really interesting. The battery concept is great.
Um, Part of it also might have been the pressure that was put on the rocks themselves. You know what I mean?
Wow. Yes,
If you put enough pressure on stone, it will actually a
retain a
thousand.
charge.
Yeah, exactly. Average $1,000. I don't know what he's talking about there. Maybe it was some of the stuff that he sold, because I know that a lot of his samples were sold on eBay, and that might be what he's talking about. My clients could never find secondary investors. About a million versions some years. Cool.
Million.
Uh, a million versions. So I don't, that could be the rock battery that he's talking about, because he is talking about Japan there, you know, 250,000 Japanese dollars. Yeah. So not sure what he's saying there. Let's see what the next one says. See if he talks about it a little bit more. Um,
Who's Gordon Doherty? Do we know?
not
Doherty,
sure.
excuse me.
Yeah, not sure. Again, we could ask Carmen. I'm still in contact with my clients. Here's hoping the spirit of Ken Shoulders is watching over this experiment. Maybe he'll give the Evos a little nudge for the others. That is so awesome. And of course, I'm gonna send this to Chris Beskar today. And Chris Beskar was business partners with Ken Shoulders, so that's a really special thing that somebody had said there. Very,
Ken
very
Shoulders
special.
was saying in his one of his books that once seen, this electrical phenomena is not easy to ignore. It's not easy to ignore.
Oh, exactly. Yep, exactly. And I think that's why they did this, and they're bringing it to the public's attention. I mean, the DoD knows about all of this stuff and has known about it right the whole time. I would suggest that this is a disclosure, big time disclosure, to have his work come out, and even to be honored to be given Ken Shoulders research by Chris Beskar. All this timing of all of this stuff is planned, and Chip referred back to that General Van Herk having the plan. General Van Herk's the head of NORAD, and Space Force is involved with all of this as well too. So I'm still in contact with my clients, which
We've
is
already
very
done this,
interesting.
so
Yep. Yeah.
okay.
Is there? Yeah. Let's see what's on the next one. And there's a very special moment. Ken and I were close. This actual screenshot I'm going to send to Chris Beskar, definitely. And then it says both governs call it national security, as I wanted the videos. Um, both governments would be Canadian and American, I think. And then I said, I'm going to send this to Chris Beskar tomorrow, which I didn't do, but I'm going to send it today, because Sunday's a good day to get a hold of him. And like I said, I'm going to send him especially the stuff about Ken, because that's really special. And also say that I am going to invite if John Hutchinson can come, I'm definitely going to invite Chris Beskar and David Wilcock, who, even if that John doesn't come, they're absolutely invited to this meeting of the minds in Penticton next summer. I think it's probably going to be in September, Carmen was saying.
Yeah.
I don't think she's got a date nailed down yet.
We got to get to that one.
Yeah. But oh well. So I'm not sure what he said there. He's probably talking about those videos above. Then go on to the next one.
Great sharp DC pulses into the ether, shock the ether.
Yep. Yeah, exactly.
Dougherty is saying, yeah.
Yeah. That is the magic. Very, very sharp pulses and very rapidly is the magic. It's kind of neat too, because there was quite a few times when there were 111 of us in watching, and there's one of the times, right? Yeah. So what does it say? Okay. This is interesting. Eric Nielsen, Canada, and Reagan, USA, Star Wars. So, Mr. President, give the youth real knowledge. Okay. I think he's referring to what I was saying earlier, but I don't want to put words in his mouth, and I don't know for sure. Got folks going on this. So okay, so he's saying that those guys got folks going on this. All right, that part about the drones is kind of funny, but let's see what else we got from John. So very, very special to actually to have these, comments. They're saying Johnny doesn't drive. So I'm told I don't drive. Living, when dealing with high profile folks, be honest, truthful. There you go. I would suggest that he's talking about probably military, EOD, DARPA folks. Yeah.
Reminds me of the Tao Te Ching. Never take advantage of power.
Yeah. Yep.
Anyway.
Yep. Let's see what else we got here.
Is that a Buddhist proverb, Brendan?
Yeah,
Taoist, Tao Te Ching.
Taoist, that's close.
So that's that.
There's all the the Therify bulbs lit up. A beautiful picture of them, 8 of them.
Yeah.
And again, Rob Harris was set up the experiment. He's the inventor of the Therify. So it was kind of special to have him as well, too. Very special.
Did he buy these from Dan Winter or from the original guy? Or?
Well, he invented them. So
yes, he built them himself, probably. Yeah.
Yeah, exactly. Or whoever built them, those are his essentially, right? I think there were 2 controllers there. I noticed. Oh, there you go. Back to there. Nancy, John Hutchison's wife, has a great YouTube channel. Boom. I did not know about that. See where it says that, Nancy? That is fantastic information. We're going to have to dive into that a little bit deeper because I did not know about that. When I saw that, I was really excited. Now he says, try magnetic fields used. I used old traveling wave tube jackets.
Try magnetic fields. What, in 3 space, XYZ? Is that what he means?
It must be, right? And then he's using, so there's some kind of waveguides that he's using, right? Because they're old traveling wave tube jackets.
Yeah.
Again, probably off of Navy destroyer stuff, right? I know he gathered most of his stuff up from the Canadian Navy.
So this is interesting. He could be creating soliton, and that's what the Grenier is talking about, the non-linearity, and then creating a waveguide, right? With the damn tubes to shrink wrap the whole damn EM field in a soliton.
Yep. It's just like we were talking about in our meditations, how the M tubes are used
Yes.
as waveguides. It's no
Yes.
difference right here, you know.
Yes.
Very, very interesting stuff. And that's why when I was going through these I think it was last night, I decided that we should go through these and talk about it because some of the information on here is fantastic. And you're getting him, candidly talking about stuff as we move along, right?
Yeah.
Yeah, it's
He,
fantastic.
there's some great nuggets in here.
Yep. Yep, exactly. Let's try the next one and see what he has to say. We're probably getting pretty close to the end. And then we'll dive into the work of Ken Shoulders that Chris Beskar was so awesome that he gave us that. There was more Hutchinson effect in interviews. There's many written reports. I hope Matthew can upload. Okay, who's Matthew? And yeah, very important for replication of this. So he's pointing us to where we need to look.
Alex, I can hear Bob saying it. Very important. There's something above that he's referring to.
Yep. Yeah. And of course you guys can listen to this live, right? It's a 4 hour one. And kind of because Bob Grenier talks to John Hutchison on it quite a bit. And they're going back and forth, and that's where some of this stuff is coming from. So very important for application of this. Let's see what else he has to say. So you can upload it. Take a drop.
In there.
Let's see if there's something at the bottom of that. We are doing now at night. Oh, so he's talking about the experiment, essentially, saying this is what we're doing at night. And this is interesting. The ancient pathways, that's one of our guys who jumped in and realized it was live. Yeah, it's kind of cool. He didn't I think I might have posted it on one of our backstage. I think I posted it on, and he was up at the time. It was Evan, Chip, the ancient pathways. That's Evan, his comment
Yeah, I
there.
remember that now. Yeah.
Yeah, yeah. Let's see
Sounds
what.
like Ebeneeze. Oh, snap, it's live.
Yeah, exactly right. He jumped right in the middle of it, which is kind of cool, right? Let's see what the next one says, because I think I might have had a comment right after that or something.
Jesus, there's a lot of voltage in those Therify bulbs.
Yeah, love this. Thank you, Bob, Paul, and fans, and absolutely, we're all fans of Bob.
Which Paul is
Um,
this? Is this our Paul or a different Paul?
um,
As Paul
that
was
would be
going,
Paul. No, that would be Paul Harris. Paul Harris, the inventor of the Therify, who's this whole experiment was set up by Paul Harris. Yeah. So all those Therify bulbs, he invented those Therify bulbs. Like
and Bob is
Chip was
Bob. Bob
asking.
is Bob Grenier. Bob
Yeah,
Grenier.
Bob
Yeah.
Grenier. Yep, yeah, Paul and fans, and we're all fans. And I just said very grateful to have you and everyone. Thank you. That's Technology Envoy. That was me. And there's our Paul right there.
Yeah, yeah, that's right.
Yeah,
Okay.
much love. All right, he was there as well too. So that's kind of cool. And I think maybe the last ones will just be there's one here of a screenshot that I took talking to Carmen about
Do you want to look at?
John.
Do you want to check? Do you want me to do the
Yeah,
next
yeah,
one?
just keep going. Yep,
See. I don't want to lose my place.
yep.
Um, um, I can remember. I can remember.
It's right at the very end because we're just
Yeah, it's
about
here at the
done.
bottom. Yeah.
Yeah, yeah, it's that one, and then the next one. Okay, so this one says, let's do
I
that
think
one. Let's do that one
have
because it
we done?
says something.
Have we done this already? I think I lost the place. That's why I was trying to find it again.
Yeah, we
Um,
did do this one.
Oh
it
Yeah,
yes, we
says,
Doctor.
did. Yeah, no, go right to the bottom then, and then we'll go back up because we're done
oh,
basically.
okay, go right to the bottom.
Yeah, so we looked at that. So don't. Okay, go up, and that's what I wanted to show you. But go up one more. Let's just see if there's anything on there. No, so that was the last one. And then this is the screenshot. If you go down again, this is the screenshot that I took. And then yeah, and then the next one I think is when I talked to Carmen. Yeah, right there. Oh,
I'll do
and
this one. I'll do this one.
yeah,
So
yeah, exactly. So Carmen was in the chat and then she left and then she came back. And in the midst of it all, she missed when Bob Greenyer invited John Hutchinson next year. And at the bottom of this one, oh, keep going. Right. Yeah. So it's big. It's too big. I can't maybe zoom out or something. Yeah. So basically, I sent a text to Carmen and I said it was priceless when Bob and Paul invited John to Penticton next summer. And she said, I missed that. Right. And, but he did. And it's on the video essentially. So cool. We're done with that. Maybe what we'll do now is if you guys have any questions, let's talk a little bit, and then we'll jump back into Ken Shoulders, and we'll do the one that we were trying to do last time. Yeah, we'll do this. Yeah. So is
So
there?
Ed, can you
Yeah,
hear me? Okay. Can you send a link for this video?
yeah. I
yes,
will. Where could we put this? Are
On the chat.
you are you in the signal in our signal group?
Yes.
Okay.
For Dave's signal group, yes.
Okay, why don't you send me a request and I'll get you into what is called the Intergalactic Starseeds signal group, and that signal group is connected to these meetings, and I'll make sure that I repost everything that we're talking about here as soon as you jump on there, because you won't see any of the stuff that was before that. And Chip, also, if you're interested too, just let me know and I can add you in there as well too.
Yes,
Okay,
please.
thank you.
Okay, cool. Actually, I think I can find Chip in there. Yeah, just send me a request and I'll make sure that all happens for sure. And this was really late Thursday night. I think they timed it so that John in Germany would have been early in the morning for him, kind of, because I was wondering why we did it so late, because I got done at 4 in the morning, right? So
Is he working on a project in Germany or is he just hiding out there?
no, that's where he lives. Yeah,
Oh,
he's lived in Germany for quite a while. And when I asked Carmen originally, when she told me about the conference in Penticton called the Meeting of the Minds, I said, could we invite John? And Carmen said that Bob Greenyer would have to bring John over from Germany. And then
I'll just quickly go to the lavatory. I'll be
yeah,
back.
you betcha. Yeah. And then what inevitably happened was, right inside of that video, which is about 4.75 hours long, Bob Greenyer does in fact invite John Hutchison to BC for next summer. And I think what they're going to do, nobody has told me this, but intuitively, I think what they're going to do is they're going to have another experiment. They're going to do this again, the same sort of setup, but they're probably going to, fine tune it and whatnot. So, yeah. definitely. Um, it was
So
it was something that I didn't really know about, actually. Is that it? Yeah, Chris, there could be there's actually about three or maybe four of them that I want to share. But the really long one, it's all on Martin Flashman Memorial Foundation as well too. You guys can find it all there, but I'll certainly make sure that that we've got it for you. And Chris, I don't know if you're interested as well. If you are, I could put you in there as well so that you're in the Signal group. Have you ever been in Signal before, Chris?
Yeah, I have to re-download it though, because I had Signal and all that stuff, but when I put Ubuntu on the computer, I just have it on my phone. I think I have to re-put it on my computer, but
Okay.
I couldn't find it. That's why I forgot because I was looking up Bob Greenyer, and I forgot they call it the Martin Fleshman
Yeah, Memorial
name.
Foundation.
Yeah, yeah.
Yeah, yeah, you betcha. Well, I'll send me your what do I need to do that? Um I think I need your phone number for Signal. I can't remember how to do that. Oh, there, oh, Ben.
yes,
Okay, also, yeah, for sure. We'll get all you guys on there because I'm trying to share a lot of this Ken Shoulders and John Hutchison and Chris Beskar information on intergalactic star seeds, the Signal channel. So it's awesome. Yeah, we'll all get on there. There's some really great stuff on there as well too. And this one here, just while we're waiting for Brendan to come back.
Yeah, I'm back now.
Okay. I'll just explain a little bit about and thank Chris Beskar again for this information because what ended up happening was I opened up an email one day and Chris had sent me all of Ken Shoulders' patents, all of his research, everything. And I went to the printer. I have a printer in town. I had the printer printed out, and the printer screwed up because it was supposed to be double sided, but it ended up being single sided. And there's over 600 pages, so the pile was literally about a foot high,
Oh my
and
God.
I couldn't carry it. So then they what they did is they split the pile in half and put it in this box, and I came home with it. When I got home, I decided to put the two piles together, and when I lifted up the one, this actual paper fell out on the floor, and I looked at it and went, wow, charge cluster. I've seen this before, so I put together a whole bunch of charge cluster pictures that are similar to this, including the work of Bob Greenyer and even Wheeler back in 1954, even going back, and some of the research that they'd done, and it all relates back to this. So again, we have to thank Chris Beskar for giving his business partners information to us and to allow us to go through all of this because it's really, really important to the world, all of the science of charge clusters. So let's dive into this one. And I think we're just going to let Brendan read as we go along here.
Okay.
And yeah.
Excuse me. I've had a bit of a cold recently. I'm just
No
recovering from
problem.
it now.
We really appreciate you doing this.
Charge clusters. Around the end of the 20th century, US scientist Ken Shoulders created a very original electronic device on which he conducted experiments by sending ultra short high voltage impulses. He observed the creation of uncommon localized charges, spherical form and hollow, with a diameter typically between 5 and 15 micrometers, made of an accumulation of 10 to the 8 to 10 to the 11 electrons. Ken Shoulders called these charge accumulations electrum validum, strong electron, while their contemporary name is charge clusters or condensed plasmoids. He studied their behavior, lifetime interactions with various metals, etc. To our opinion, Ken Shoulders made a great discovery in the field of high voltage electrophysics, while several other authors developed theories and wrote various publications about these exotic objects. This section is providing a selection of publications by Ken Shoulders, by our chief scientific advisor, Vladimir Sapojin, and some other publications describing the charges, the charge clusters, so our readers can better understand those physical objects which are deeply involved in real text, innovative energy storage technology. Publications by Ken Shoulders.
So I just took a bigger screenshot. I just wanted to show you guys a little bit closer, bigger screenshot of this.
I'll put this in. So
yeah, charge clusters. These structures are very, very, very important to all of the science, essentially. And I think that this was probably a computer-generated version, where we do actually have. I actually have pictures of charge clusters. And charge clusters forming, as a matter of fact, that were given to me by Chris Beskar and David Wilcock at Stabati Aerospace. So yeah, that is a very, very important structure, and in fact, possibly the only structures that we have actually when we talk.
And is there any?
Oh,
right.
Yeah,
Is there any theory behind this as to why they self-assemble into these toroids?
I think it's actually all part of the structure of the universe itself, actually, that these toroidal structures form. Yeah. Hey, Ryan, how's it going? It's great to see you, man. We just went through, and I was live when John was in the live chat the other night, when they're doing that experiment. And were you there with them, or where are you now, actually? Because I know that you're with Carmen there at one point.
Hey, Ed, are you talking to me?
Yeah.
So I wasn't able to go up to Paul's house with Paul and Bob, so I wasn't there. But I was at Carmen's house, and
yeah.
Then afterwards, the last day, Bob came to Vancouver and met Carmen and I there.
Okay.
And we had some time there, and then slept, and then went to the airport. So I had a few hours directly with Bob where I got to delve into some things with him, although we didn't actually talk much about the experiment that they did.
Yeah. And I was just telling the guys that we're going to send this one to Chris Beskar. So I was talking about the letter that you had found from Richard Feynman apologizing to Ken Shoulders. Yeah, if you want to bring it up,
I can put that up.
Cool.
I can bring that up.
Yeah, because Ryan is the person that brought it to our attention. He's the one that found it. And
hey, Brendan.
Yeah, this letter right here. And
that's a good copy of it, nice and clear.
Yeah, exactly. Yeah, I think we have to thank Paul Asteros for that one. I believe he found a really nice clear copy of it.
And by the way, I should mention I met Paul Asteros there also, and he did a masterful archiving job with what he was able to do over those few days. It was probably just a fraction of the total volume of stuff there, but nonetheless, I was really impressed. And he's been loading up his Discord server with a lot of it as well.
Yep. Yeah, exactly. Yeah, his information, and like you said, his ability to grab everything together and put it in there is truly amazing. Yeah, for sure.
Brendan, could we bring that letter back up real quick? There's something in the middle that caught my eye.
Yeah.
I don't know if Feynman's talking or Ken Shoulders is talking. It's kind of incidental.
It's all,
Adjustment of
this
the
is
size,
all Feynman. This is all Feynman talking to
at the
Ken.
very bottom, by the adjustment of the size of the quadrupole field of the forces of confinement can be made equal in all directions, just as if there was a density of ions in a vacuum and a rotating sphere of charge is possible.
Yeah.
Jesus, that's a mouthful.
Yep. And that's basically he's I think he's working it through in his mind that this is a possibility,
Yes.
and I'm sorry that I didn't listen to you, basically, is what he's trying to say to Ken Shoulders.
Yeah, that's
This
exactly. And what I figured is that when Ken Shoulders initially approached Feynman, he must have Feynman must have thought that um, at least off the cuff that it would be impossible to stabilize these structures.
Yep.
And then it was only later that he realized it was possible if you impart a rotation. And then of course he goes so far as to give some back of the envelope calculations as to what he thinks would be a reasonable scenario as well,
Yeah.
which I found to be particularly revealing.
So, Ryan, additional question. By rotation, is he implying he's trying to control the spin of these trillion electrons, basically? Is he trying to give a grain or a shape to the spin in the charge clusters?
As I understand it's I guess what you could consider uh, a rotational moment of the entire body of
Okay.
electrons
All right, so that creates some homogenation.
about a center.
Yeah, I could see what it could smooth it out here, but most important comment in this whole letter is the first statement. By adjustment of the size of the quadrupole field, we can create and shape and control these charge clusters. Well,
Yeah.
how do you do that? How do you control the quadrupole field, the Lorentz forces? How are you going to do that? Femtosecond lasers, we're talking about the DC pulses here to create this whole effect.
Yep.
And the same thing is being discussed here. Adjusting the size of the quadrupole field is probably done with these very, very, very short femtosecond or shorter pulses that
Pulses. Yeah.
homogenize the
There
field.
is there are some analogous things that I'm aware of in accelerator machinery as it exists.
Yep.
So quadrupoles are firstly they're a part of the achromat lattices, which are a series of magnets consisting of a dipole, a quadrupole, and a sextupole closely spaced,
Yeah.
and then repeated. And those are used to alternately focus the H mode or the horizontal mode and the vertical mode of uh, the um, the wave structure of the beam. And of course, we're talking about a standard electron beam.
Yeah.
And
you
also
reverse
the beams bunch, and there's a function that the achromat lattices have with regards to how the electrons bunch in the beams into what they call, well, bunches. They actually call them bunches.
Yeah.
be damned. I'll be
And
damned.
then there's another place between the um, accumulator ring and the storage ring. There's an electromagnetic septum and kicker magnet, and this kicker magnet is fed by a voltage adder, and that voltage adder is optically switched, and it switches on the order of somewhere around 10 nanoseconds, if I remember correctly. It's
Wow.
very, very fast.
Yeah.
And it's done with MOSFETs, MOSFETs that are basically driven at the top of their gating power, so that they switch very abruptly.
Very fast. Yeah.
Yeah. Wow. And
So it's not
Ryan,
infeasible, not by
Yeah,
a long
no.
shot.
Yeah, no,
And-
that's interesting.
and Ryan, could you tell us? I think you just finished a contract somewhere. Could you tell us a little bit about yourself and just so that Chris Bescart knows as
Sure.
well?
And just to know that you know that we're recording this, don't you? So
Yeah.
Sure.
yeah,
Yeah.
okay.
Thank you. Yeah, so I'm an engineer and a draftsman. I've been in the trade for going on 20 years now. And most recently, I just finished up a 1 year work contract at Berkeley Lab, aka Lawrence Berkeley National Laboratory,
Yep.
the birthplace of the cyclotron.
Yep.
And my role there was that I drafted all of the control cables for the machine protection system for ALSU. ALSU is the coming upgrade to ALS, which is the Advanced Light Source Synchrotron, on site at Berkeley Lab in the big pink round building.
Wow. Very, very cool.
The 600-foot diameter synchrotron light source that has 40 beam lines with
Wow.
user stations with experiments set up on the beam lines.
Wow.
And currently it operates at about 3 GeV. I think it's 3 GeV, and it's the upgrade will essentially add about another GeV to the beam power and improve the beam current from 500 milliamps to I think they're trying to get up to about twice that with the beam current as well. And
Wow.
in addition to that, an entire new set of achromat lattice arrays, which will greatly improve the focusing of the beam. One of the current problems with ALS is that it has a fairly wide horizontal beam spread, even though the vertical beam spread is pretty good. So that's going to improve the horizontal beam spread greatly, so that it's a much more tightly focused spot with higher power, which should be a significant upgrade for ALS.
Yeah, a refinement. That's awesome. We're so grateful to have you in the group here, Ryan. And I always
Thank
have
you,
to
Ed.
thank Carmen also, because she was the one that connected me with you. Yeah, and this letter is mind blowing. I I'm sure that maybe Chris has seen it, but I'm not 100% sure. So I am going to send it to him today after the meeting here, along with this recording and whatnot. So yeah, very,
Right
very
on.
grateful.
Just a
Uh,
quick question, if you don't mind.
Yeah.
So when I first joined, I saw there was a tab open that had what appeared to be a nested toroid structure.
Oh,
Would you mind going back to that?
When you both join the meeting, yes, that's fine. Yeah,
yep.
that's right. So
Yep. You for
the
sure.
onion.
So as I mentioned before, I had some direct time to talk with Bob Grenier,
Yep.
and one of the specific things we really got into was his ideas on the formation and stability mechanism for these nested toroids,
Yep.
which I found to be very interesting, especially the implication that as you go up in order, they get more stable. And
Oh,
obviously, one of
wow.
the other consequences is that they're the amount of energy that they can contain increases as well.
Yep.
And what I realized was that this, as a consequence, this leads to two ideas. One of the ideas alongside scale invariance is medium invariance, and uh, the other one is the time scales that large ball lightning orbs have been observed by many people
Oh, yep.
to obviously have to exist over, like seconds to minutes time scale.
Yep.
That should be a natural consequence of this stacking stability as well.
Wow, that is so cool.
So
So
Ryan,
Ryan, what are
where
your
does the sorry, you go, Chip.
Ryan? What are you referring to And you're talking about up in scale.
So what Bob
You've-
described to me was essentially the idea of fractality in a toroidal structure.
Yeah.
A normal, let's say, toroidal coil would be a simple toroid, or a one toroid.
Right.
And then if instead of simple straight piece of wire being used to wind that toroid, you instead used a tightly wound coil, then that would be a doubly nested, or a nested toroid, or a two toroid.
Yeah.
And then a doubly nested toroid would take that one step further, and you would call that a three toroid.
So,
And then a
so,
four. Yeah.
So
so
Yeah.
Ryan,
there's one
how does this
specific thing
relate?
that, sorry?
How does it relate to free energy or over unity?
Well,
Well,
The charge clusters.
I can answer that.
Answer.
Charge clusters from Ken Shoulders are the clutch that engages the ether. So if you want to do work and get work from the ether, this is your method, is to use these charge clusters. And what Ryan was saying, as you move up in fractality, they become more stable. That is fantastic, actually, to think about that.
So in a sense,
And
they're
they can
drawing
both.
energy from the 0 point. It's like they're drawing energy from the ether or the 0 point. Is that
Yeah.
right? Is that
one
Yeah.
way that you might think of it is so the idea that I mentioned of medium invariance.
Yep.
So we talk about scale invariance. I personally, I think that this concept of medium invariance is potentially just as important.
Yeah.
And what keyed me into it was something that Ken Shoulders
Go away.
himself said in the beginning of his book EV: A Tale of Discovery. And it kind of perplexed me at first, but he said something about that electrons could be condensed to the density of uh, excuse me, to the density of solids. That electrons could be condensed to the density of solids, and I kept thinking about that
Wow.
the whole week I was at Carmen's place. And what that means to me is that that ties into the scale invariance as well, and the concept that these charge clusters can contain a density of electrons that can exceed the Coulomb repulsion limit.
Yeah.
What we are taught by the convention as the Coulomb repulsion limit. So one thing I realized that was connected to that also is that so this is a structure, right? If we look
Yeah.
in other media in which this same toroidal vortex structure occurs, like smoke rings in air,
Yeah.
or water bubble rings in water, or even saltons in water, where you see like a double dark spot, and they're counter rotating and they travel across the surface, or they even go all the way down to uh,
Yeah.
the bottom of the pool, and they'll travel around, right? They
Yeah.
persist for a long time.
Yeah.
So by analogy, medium invariance should imply that this kind of structure can also occur in the vacuum.
Yep. Yeah, definitely.
Yeah, that would be the source. And
Yeah.
so that's also the reason for the achromatic aspect to the matrices you're talking about. You need white light, obviously, or a normalized material as also a medium. The whole damn thing is normalized by stirring it. And the issue what Feynman was concerned about with the Coulomb charge is in the letter.
Yep.
That's what
Yep.
prevented him from getting on board in the first place. Oh, they're going to bust
Yep.
themselves up. But it gets dense enough, and that density triggers some kind of negotropic effect, a self-assembly into a very stable toroid. And like we just asked Ed here a few minutes ago, what, do I have to thank source for that, or can I actually apply some mathematics and figure it out?
Yeah.
It's an
Yeah.
electrodynamic soliton.
Yeah.
And that's the connection
Yes.
to
Not
SQK is that
electrostatic, but rather
organization.
electrodynamic, because
Yes.
we have this
Non-linear.
idea
Yes.
of a an inwards a structure that's spiraling inward on itself, right?
Yeah.
Um, so that leads to the idea of sort of a charge sheath, which is something that Mark Tomian talked about also.
Yeah.
But in this structure, this charge sheath wrapping in on itself would create a well, you guys know uh, what happens when you have a moving electric field? Hooper effect.
Yeah. Well, you create magnetism in all directions too, but um,
Are
yeah.
you guys aware of uh, Dr. William H. Hooper? He it's very interesting actually. I had read his work before, but
Yeah.
seeing it again and in a new context and with new eyes,
Yeah.
I saw that he actually worked at UC Berkeley, and his concept was of a motional electric field that cannot be shielded by traditional means, and this led him as a logic of consequence to the idea that electromagnetism and gravity are intrinsically linked
Mm,
through what he called the electrogravitational field.
yeah.
Uh, as I mentioned before, Mark Tomian also mentioned Hooper, and he used the equations for the Hooper effect as part of his design process for his electrodynamic field generator,
Yeah,
Oh,
Paul
cool.
Laviolette
as
in
well as the cyclotron equation.
Paul
Wow.
Laviolette in some quantum kinetics book is talking about the coupling between charge and gravity.
Yeah.
It gives a coupling
Yeah.
constant.
Yeah. It is in there for sure. It's like the
Electrogravitics need.
holy grail of physics almost kind of actually. Yeah. Wow. Super interesting.
It implies that super forces controlling EM, gravity, longitudinal fields, you name it, the whole darn thing.
Yeah.
So, does anybody know of any math that can model these types of structures and predict tensor overlays, if you will, in developing it in three-dimensional space and time? Is there any math that predicts the formation of these rings, and can it therefore be modeled?
I
Because
wonder
if
if
you
some
could,
quantum kinetics can do that. I wonder if
That's what I was just
yes,
thinking, Brendan. That's what we need to really start
because
looking into.
Paul's version of Maxwell's, I was going to say in Maxwell's unaltered equations,
Yep.
I heard there was four more equations. He had eight
There's
originally,
20. There's 20.
20.
yeah,
And
the
those
ones
other
that are
ones were
not
to do with
ditched up.
longitudinal. So in its current form, in its conventional form, the four Maxwell's equations are transverse. But you're saying the other
Yes.
ones were more to do with longitudinal. Is that right?
Hmm.
So the whole point of the discussion is that if we can model this, then we control the size of this field effect that Ryan is talking about. All right. And then we can manipulate the charge clusters and the goddamn spin that goes along with them. You heard me
I
a few weeks ago
personally,
talking about that.
Chip,
I can't get
I
away from that
agree.
either.
I concur with you. I think that the the electrodynamic and fluid dynamic conditions uh, can be modeled in a multi-physics FEA environment.
Wow, that's great.
Yeah.
Yeah,
And
no, geez.
the how we create these charge clusters are actually all part of the Ken Shoulders patents that this group is going to be going through because we have them all, right?
By
And
the way,
yeah,
there's another very interesting body of work that Bob Grenier mentioned to me and
yeah,
actually showed me his copy of. And this is this book is actually available online, but it's kind of expensive. But um, it's called Controlled Nucleosynthesis,
okay,
and it's the story of the Russian Proton 21 lab,
Yeah.
where they basically independently did uh, pretty much all the same uh, foundational work that Ken Shoulders did.
Yeah.
But they also found a means by which, with some high power pulses, they could not only create charge clusters, but they could create charge clusters that, when impacting on metal targets, would create transmutations, and not
Yep.
just transmutations, but a wide variety of transmutations. They actually have
Yeah.
a chart that shows that almost all of the elements are actually uh, uh,
Yeah.
transmutated out
Yeah.
of these impact events, which
Um,
I found to be very
yeah.
intriguing.
As a matter of fact, Ryan, this is the third time that we're doing Ken Shoulders stuff. It'll be called Ken Shoulders number 3. I think it was the first one where it was the Russians' research where they shot charge cluster through 99.99% copper slug, and out the other side, they did metallurgical analysis on all of the probably I never counted them, but there's probably at least 20 or 30 different things on the other side, and it's all part of the Russian
Yeah.
research. And in fact, when we carry on with what we're doing today, half of this talks about Ken Shoulders, but then the other half actually talks about a Russian. So Ken, the Russian research is so critical to all of this, and Ken was right there with them, as was Chris Beskar. Because they were business partners, right? We always have to think about Chris in the background, knowing about all of this stuff without a
So
doubt.
in a sense, these charge clusters, they're generating energy. They're like, a bit like.
So, Brendan,
On.
it's called HDCC, and this is comes out of the Ken Shoulders patents again, high density charge clusters. And what they were trying to do is they were trying to figure out exactly how much energy they could pack into these structures. And it turned out to be incredible amount of energy. And so that's
And that
also,
energy came from, say, the ether or something like that, or like the 0 point or whatever.
absolutely. It's all
So
drawn
you're
off
saying it's
the
like the
ether.
clutch. The clutch is tapping into the 0 point or something like that.
These structures allow us, like I said, Ken Shoulders' exact words are, these structures are the clutch that engages the ether.
Yeah.
So if
Huge
you want to do
potential.
work, yeah, exactly. You want to do any kind of work, then you're dealing with these. And what we're doing is we're spinning them up faster and faster and faster. And Chip and I are in another group with Dave Rossi, who is doing some research with the US government. And one of the things that he talks about a lot is how basically we only have this one structure. And when we spin the structure up to the speed of light, then it changes. And then we have something called a graviton. And
So you're
that's
talking
the
about
actual research that
spinning
he's
it up
doing.
to a rotational, like in analogy to a phase velocity, a rotational velocity matching C.
Yeah, it's all
That's
about
interesting.
velocity. Yeah. He talked about how, in the lab, all that they really see is this one main structure, or is this structure. And then as you spin it up, yeah, when you get to the speed of light, then it changes into graviton. I want to show you guys something that came from, and this has a lot to do with everything we're just talking about. Because of NORAD, I've had these for a really long time. These are room temperature superconductors. I've got 2 of them. And this was developed, so when they went from diesel submarines to nuclear submarines with NORAD, this was developed by Dr. Jack Bybee. And it was actually developed for the passive part of the sonar system. So when the subs got quieter, they were actually trying to make the sonar systems more efficient and whatnot. So they actually hopped up the electronics, and then they went to Jack Bybee with this thing, and it's called a quantum purifier. I've had a couple for about 25 years. I played with them a lot with audio. We'll talk about that with you, Ryan, later. But what's really interesting about this is signal coming into this. Typically, most signals in a wire travel about half the speed of light, so 0.5 C. Now, it goes through this. When it comes out the other side of this thing, it is doing 0.93 C. So it goes from 50% of the speed of light to 93% of the speed of light coming out of here. Now, I always wondered why they stopped at 93%. Like, why didn't they go to 100%? And the answer is in just what I told you, what Dave told us. If they spin this up to the speed of light, this thing will literally just explode. It will disappear. So in order to keep it contained, they only went to 93% of the speed of light. So that's the work of Dr. Jack Bybee, who did all this stuff for NORAD, essentially, a very, very long time ago. So that kind of talks about spinning these structures up. So inevitably within here, there has to be charge clusters at work, spinning everything up as well too, right? It is a room temperature superconductor. It is not graphene. They are not graphene because there is I think it's the third part of the PIUS patents that come out of the US Navy that is room temperature superconductors. The materials within these are not graphene. They're other materials essentially. So, yeah.
So,
Very cool.
Ed, a couple of quick questions. This is absolutely fascinating because, like I implied here a couple of weeks ago, I'm trying to conflate all this with this modeling of T of XYZ. You know, temporal anisotropy in spin is also embedded in this. So why is it that charge clusters can transmute a material, soften it, and or make it something different? What is it in the engine room that is creating that effect?
It's the black hole, white hole setup where it's like the yin and the yang, essentially, is the way I understand it. And this is the actual the heart of the research that John Hutchinson and Ken Shoulders and everyone, that we're talking about. And
Beskar, yeah.
And Chris Beskar. And in fact, we're going to go through, we're just starting to go through these 600 pages of research. A lot of the questions that we have are actually within that research. And
so does anybody know, and Brendan and Ryan jump in here, does anybody know of any physical chemical process that would predict charge cluster variation, the actual charge itself, not the spin, creating variation in the flavor of quarks? Because from what I understand, the only way to transmute a material, change dog shit into gold, is to change the flavor of the quark. And the only way to do that is to change the spin.
Yeah.
And so it isn't necessarily the damn charge, I don't
From subquantum kinetics, Brendan will describe it. It's a little bit different viewpoint, I think, right?
We have X, Y etherons that represent the two polarities of charge, whose spatial displacement produces the magnetic phenomena, and the G etherons are the gravity phenomena. So Paul has his version of Maxwell's equations, but in terms of the ether. And the G etherons may be, Paul said the G etherons may contribute to magnetism. We don't know yet. But what am I going to say now? So
it's a little bit
he does describe
viewpoint.
the strong force, the nuclear force. That can also be described in nuclear, but he doesn't deal with quarks. He thinks quarks are just fragments of particles. He doesn't think that the quark models just appears to be correct. It's not actually. He thinks it's not actually correct. It just appears to be correct.
Hard to test.
But like Ptolemy's epicycles, but he thinks quarks are fragments of particles. I need to look up what he says about the nuclear force. But he thinks, so he's saying there's maybe trillions or quadrillions of etherons making up a proton or an electron or a neutron.
Yeah.
And
so
then
I think
spin in conventional physics is intrinsic angular momentum. of a particle. It's this up arrow, down arrow. It's a fairly simplicity. They don't really understand it. Paul says they've just assumed it. They don't really understand what spin is. They just
Okay.
a simple model that they just assume it's this, and it seems to work out quite well. It can
Yeah.
explain a fair number of phenomena, but he's saying they don't really understand what it is. They just make an assumption, which seems to be accurate to a
Yes.
certain extent. But
Yes. And so
but the spin is the etherons. The etherons, the vortex of the etherons.
Yeah.
The
right.
vortex of a particle vortex of X, Y, and G etherons. So that
Yeah. It's
So I
always
think we
etherons.
understand if we take a proton gun, for instance, in a cyclotron and fire it at a piece of material, we're going to change it. We're going to change its atomic weight. All right. So, for instance, Bob Lazar's Moscovium antimatter reactor, right? You create a proton gun, you fire it at the Moscovium, becomes livermorium. That decays to flerovium, which is 114. Livermorium is 116. In the
Yeah.
whole shit show, out comes a whole bunch of antiprotons. Well, that's pretty cool. It's an antimatter reactor.
Yeah.
But that
Yeah.
is done with protons, adding to the atomic weight of the material. That's physics, chemistry 101. I want to know what is it about the damn charge clusters at extremely high electron voltages that can actually transmute a material and change its atomic weight. And so the whole issue of not understanding the quarks, I think maybe, or the flavor and the spin of the quark may be embedded in this process. That's all I'm saying. And if we, and time comes involved, right? We start spinning up Ed's superconductor over there, getting close to the speed of light. Now gravity, the angular momentum on the spin is gravity, and the spin rate itself is what? Time. So now we're messing with time, and we have an anisotropic temporal anisotropy field. And if we can create that with gravity, we can also change the spins. And we have to add it to the standard model. T of XYZ is not in the standard model of physics. You know, we kind of forgot that Maxwell was working on it, and then he bitched up his equations.
Yeah.
Who did that? Heaviside or Lorentz or
Yeah.
somebody
Heavy
bitched up
side.
his equations.
Heavy side. Yeah.
Yeah, tore the whole thing apart. We're on the track. So all I'm saying is I don't think we can forget the spin. And then Ryan is talking the achromatic aspect of having a very homogeneous medium around that, and then creating the space field. Well, that's Sparky Sweet all over again, talking about the conduction around a copper wire being outside of the copper, being in the space field. So we're at this point in our understanding of physics. We're trying to pull all this shit together. The spaghetti splattered all over the wall. And so we're really close in some cases. And I fully agree. My camera refuses to focus properly.
Yeah.
I fully agree that the secret of the universe is exactly where this clutch, as Ed describes it, is grabbing a hold of and creating all these potentials from the etheron fields, from the quantum vacuum field. You grab it, you poke it, spin it, torque it, shit, whatever you want to do with it, and it gives us work.
Yeah.
And immediately tries to self-assemble back to stability. So it's constantly reciprocating. You know, what were we talking about that recently, Ed? What on a terahertz frequency, the whole goddamn universe is reciprocating and trying to find the stability point.
Yeah. It's back
So
to the
anyway, yeah, I'm talking all over the fucking map here, but we're getting really close to lining up the ducks.
Yep, for sure. Well, let's dive back into Ken Shoulders' work here, and he's going to talk about the Russian one of the Russian researchers that he's connected to. He's connected to quite a few of them.
this one, Eddie.
Yeah. I think we were right at we were there, and then we're going to go to the next one, and we'll just let you carry on reading. So.
Okay, I'll just carry on reading. Ken Randolph Shoulders. Ken Randolph Shoulders, March 7th to 2029 to June 7th, 2013, was an experimental physicist. He is known for various work related to the field of energy and has also been credited as an early pioneer of electron lithography, which has become a key mask-making technology for modern microelectronics. He has additionally been attributed the title father of vacuum of microelectronics and has been known as a founder of microelectronic field emission devices. He graduated from North Dallas High School in 1944, then worked at Maganovox Company, Texas Instruments Incorporated, and Collins Radio Company. 1955 to 1958, he worked as research staff member at the MIT, which is Feynman was there as well. I don't know if he's there at the same time, but he joined, as if it's the same MIT. He joined the Stanford Research Institute in Menlo, what's that, California,
Yeah,
in
yeah.
1958 as senior research engineer. 1968, Ken Shoulders incepted Vertitech Incorporated with the intention of building experimental aircraft. During 20 years, he designed several aircraft and aircraft components, but never managed to successfully commercialize products. Ken Shoulders has conducted extensive research on the charge clusters, EV or EVO, phenomena between the 1980s and 2010s. He was awarded a number of patents over the course of his career. We recommend you also read the very good biographical article published in autumn 2016 in the journal Distillations. Ken Shoulders, EV, A Tale of Discovery, 1987.
You guys might have heard of zero-point energy. Ken Shoulders was the man that coined that term, zero-point energy.
All right. This is the main monography of Ken Shoulders, where he describes how he registered the discovery of charge clusters, which he called electron validum. Their physical properties, the devices, and numerous experimental equipment he developed in order to measure the EV parameters, quantity of charges in one cluster, lifetime geometrical form and sizes of craters when they hit Titan foils, etc. New energy transformations have been found using highly organized micron-sized clusters of electrons, or EVs, having soliton behavior, with electron populations on the order of Avogadro's number. When interacted with solid material, these charge clusters perform a low-energy phase transformation type of atomic disruption that liquefies the lattice and propels the material to a high velocity without apparent signs of conventional heating.
Wow.
Evidence will be introduced for the underlying energy production process stemming from the equivalence of an electron annihilation energy release based on the manipulation of fractional electronic charge. Evidence will also be shown of how a low energy nuclear reaction has produced nuclear transmutations by using a nuclear cluster reaction process. Highly organized micron-sized clusters of electrons, or EVs, having soliton. Is this the same? No, it's not. Soliton behavior with electron populations on the order of Avogadro's number are represented as the necessary function for modifying the permittivity of space in a downward direction.
Bingo.
The state of existence for this entity reduces its expressed charge by many orders of magnitude below that calculated for the same number and volume uncontained electrons. The EV is shown to exist in at least two distinct modes of charge masking, with one of them, the black EV, being virtually undetectable using sensitive methods. A form of inertial propulsion will be discussed that arises from the inertial rectification effect available by modulating the state of the EV thereby the permittivity of space and the concomitant inertia and effective mass of material moving through space. It will be shown that the same type of permittivity change through EV modulation can achieve a unidirectional current flow, and that this gives rise to methods for generating monopole effects and vector potentials useful for communication outside the usual current loop generating them.
Wow.
Complex organisms are composed entirely of EV structures that are self-formed at electronic states without, electronic rates without using either mechanical or chemical methods. Some speculations will be made on the benefits of operating such complex entities in regions of greatly reduced permittivity.
So the permittivity is a really important part of all of this.
Yeah. If I could just jump in real quick.
Yeah.
I'm sure you guys might probably already be aware, but the concept of changing the permittivity of free space is a highly heretical concept in the convention.
Well, it has impedance, right? It has inertia, the vacuum. And the permittivity is kind of a generalized, sloppy current explanation for that, in a sense.
Yeah.
Yeah.
You got it, Chip.
Mm-hmm.
Okay, a condensed matter dissolution technique will be shown that is capable of cold dissociation of refractory material into a low viscosity fluid. The root process for energy conversion methods resembling cold fusion are reviewed and shown to likely spring from the same EV technology capable of producing a modified space permittivity. Consideration will be given to experimental methods for testing effects on time at greatly reduced levels of permittivity. An EVO, exotic vacuum object, is just another name in a long line of names for the new electronic effect. In the past, it has been called an EV, electromagnetic vortex, or electrum validum for strong electron. Charge cluster, this could be just a piece of dirt with no net charge. And CCT for charge cluster technology. Whatever it is called, the effect can best be characterized by how it is measured using instruments capable of interpenetration in terms of somewhat similar phenomena. We will assemble a series of observations characterizing the observable entity properties that are most pertinent to new energy and propulsion uses. Pertinent, yeah, that's right. This note by Ken Shoulders is an attempt to analyze the actions and basic characteristics of the entity while being as free as possible of preconceived notions about its structure. An EVE or exotic vacuum object begins its life by accreting electrons extracted from gaseous or solid atoms. It then self-transforms into a coherent structure, behaving as an entity functioning at greatly reduced expressed charge compared to the number of electrons either put into it or extracted from it at this stage in its life. This note will present main features about EVO's behavior. Very interesting and straightforward answers by Ken Shoulders about the natural questions may be asked about the EVOs.
Yeah, it's the self-transformation process that's kind of mysterious.
Yeah, once we dive into the methods that they use to create these charge clusters from the Ken Shoulders patents, and I've got some stuff that Chris sent with David Wilcock again years ago that talks about all of this. And now we're going to dive into the Russian researcher who is very connected with Ken Shoulders' research here as well too.
Vladimir
Sapagin. Yeah. Vladimir Sapagin.
Yep.
Vladimir Georgievich Sabagin. Vladimir G. Sabagin, born 1945, is a PhD in physics and mathematics, as well as a professor at the chair of physics of the Taganrog Technological Institute. Depends on the Southern Federal University of the Russian Federation.
Yeah.
He is a professor at the Russian Academy of Natural Sciences, worked several years on the bald lightning phenomena, another form of charged cluster, and knows also well Ken Shoulders' work. Vladimir Sapogin is the scientific senior fellow of Friel Tech's team and has built various physical models with respect to the electron emission of cathodes in various conditions, and for the calculation of the storage potential of some of the vacuum capacitors prototypes developed by our team.
That's important. Vacuum capacitors.
Ken Shoulders' charge clusters physical aspects of the phenomena in Russian. 2019. In the note, the physical aspect of experimental discovery of charge cluster by Ken Shoulders in 1987 and its influence at the process of breakthrough development of various fields of physical knowledge domains is discussed. There are the following. 1. The technologies of creation of microscopic auto-electronic cathodes for vacuum diodes, triodes, and tetrodes, and effective charge integrators of new generation. 2. The self-consistent theories which explain the reasons of fields holding of similar charges and distribution of their physical quantities in the cluster. 3. The researchers of new class of clusters reactions appearing under the interaction of charge clusters with metals crystal lattice. 4. The effect of holding the charges at the surface of the conductor in high voltage electrophysics. The comments to the works of Shoulders expanding the terminology of new knowledge division by the name of charge clusters have been cited. The repercussions of the latest revolutionary in physics are discussed, and the set of experiences which have no adequate explanations are adduced. Monograph: Mechanisms of Substance Confinement by Self-Consistent Field in Russian. V.G. Sabagin, 2000. This work underlines the discovered ability of a self-consistent field to maintain identical particles accumulated in a limited volume of space. In these accumulations, Bernoulli force compensates the Newton attraction force, and the accumulations of identical charged particles it compensates the Coulomb repulsive force. These spherical accumulations are usually hollow in their centers. Hollow micrometric charge clusters have been discovered in experiments by the US scientist Ken Shoulders, 1980. Do we need to go through all these?
Yeah, no, that's just all the research.
So I'll just leave it there for the moment so people can see it.
Yeah.
Okay.
And there's a lot of great information there.
Oh, Sapigen's still alive. Boy,
Yep.
let's bring him to Penticton.
You know what? You never know, right? That's
Shit, I'll buy his plane ticket. Let's get him over there and get the whole party going.
yeah, get the whole group there. Yeah, I agree.
These are other
Yeah, more
papers,
research papers.
publications by other authors. We highly recommend the article of Lutz Jatana, who gathered several observations and theories about charged clusters into a single article. Charged clusters are here called condensed plasmoids.
Yeah.
Here is an interesting theoretical article about charged clusters. The Russian academician Gennady A. Mesyats has developed numerous experiments leading to the observation and characterization of charged clusters in parallel of Ken shoulders. Other interesting observations of charged clusters and plasmoids, long-living luminous objects in liquid and atmosphere, physics of condensed plasmoids, and low-energy nuclear reactions, 2015-2019. LENR research was puzzled for a long time by the basic questions. To answer them, the author has built a quantum mechanical model of the nuclear active environment. LENR.
Yeah,
Yeah, low energy nuclear reactions.
yeah. A quantum model. Interesting. I assume that includes some mathematics. That's where we're missing here, Brendan.
Yeah,
We
well,
need a
how much longer is this going on for? We're on the
Yeah, we're getting close.
Yeah, we need a young PhD student to do a dissertation on this
well,
stuff.
PhD students usually do all the work. The professor just directs the research.
Yeah.
This environment is an ultra-dense plasmoid, i.e. a condensed plasmoid. The computed properties of CPs are so exotic that CPs qualify as a previously unknown aggregation state of matter. This document is first in describing the properties of CPs, condensed plasmoids.
Yeah.
The microscopic evidence for condensed plasmoids in low-energy nuclear reaction experiments, how the properties of condensed plasmoids help explaining a wealth of remarkable findings in low-energy nuclear reaction experiments. Examples of nuclear reaction routes possibly enabled by condensed plasmoids, quantum mechanical model of condensed plasmoids, computational result derived from this model, verifiable predictions derived from the theory on CPs, and a technology assessment on potential dangers of low energy nuclear reactions. So Zhang, Zion, Jin, and Hal Fox, characteristics of characteristics of high density charge cluster, a theoretical model, 1996. The model which could be able to explain the physical reasons for probable charges holding in bounded region of space by forces of electromagnetic origin has been proposed in the work. Self-consistent equations for electron plasma, which consists of continuity equation and equation of charged fluid motion, is written. This system has been considered the force. This system has been considered the forces. Was this translated from Russian or something?
Yeah, yeah.
This
Yeah,
system
that's
has been
not perfect.
considered the forces coupled with electromagnetic fields and pressure gradient. The equations have been supplemented with Maxwell's equations. The obtained system of equations is not succeeded in solution. So it's supposed that the values of electric and magnetic fields appearing inside the cluster by order of values coincide with the values given by classical electrodynamics. In assumption of homogeneous density profile of electron liquid rotating in toroid cluster, the equilibrium equation of forces passes into the radial criterion of equilibrium of such electron liquid. The estimations made on results of experiments of shoulders point out the availability of availability of execution of such equilibrium criteria.
That translation's a little rough.
Yeah. So it almost sounds like that these are the structures that naturally need to occur, is kind of what they're saying. And there's some math that we need to look into to describe it all.
Okay, A.G. Masyats. Cathode phenomena in a vacuum discharge to break down the spark and the arc, 2000. Flows of such objects appeared near uneven cathode at explosive thermionic emission. The vast density of heat energy at cathode micro asperities has resulted in explosions of electrons flow being escaped from asperity. These explosions appeared in overheating area of cathode surface, are like to explosions ejecting warmed up material from a volcanic crater. The separately formed volcanic micro explosions and overheating area have been named ectons. The ecton is an electron avalanche from metal. The estimations followed from experiments show that ectons eject by bounded portions, clusters, where the quantity of electrons is situated in the range observed by Ken Shoulders.
Mhm.
Demonstrations of ball lightning laboratory. Ergurov, Stepanov, and Shabanov, 2004. This is it. This is the last one. Okay.
Yeah.
God love the Russians. Jeez.
Sorry?
Yep.
God bless the Russians.
Yeah.
Yeah. Yeah, for sure. At some point, you guys will talk about new aerospace technologies. The book that Alexander Frolov, former owner of the Faraday Lab in St. Petersburg, Russia, wrote, and Carmen actually asked me to edit the book, which I did on paper, but then the war started, so we haven't continued with it. But yeah, the Russians tell the truth always. It's very, very important to know that.
G.D. Sabanov, B.O. B.O. Sokolovsky. Macroscopic separation of charges in a pulsed electric discharge, 2005. The physical properties of high voltage discharge of a capacitor, a conducting liquid, have been investigated in various works. At the expense of axial symmetry of electrodes, remote in water, electrical surface discharge with currents radial component at the liquid air boundary is succeeded in creation of electrical surface discharge with currents radial component at the liquid air boundary. The electrons cluster holding the current near the surface of liquid is heated more in areas with major current density. At the moment of discharge completion, the heated film of charge floats more quickly near the axis of system than at the center system's periphery. By virtue of this, a thin luminous film of charges, like ball lightning, is created. Film comes up and forms thin wall spherical cluster of electrons with thickness 0.5 millimeters, charge value of 10 nanocoulomb, temperature of 103 Kelvin, de-excitation time 0.5 seconds, and radius by order of 5 centimeters. Okay, this paper by these guys here, experimental research of dynamics of formation of long-living luminous objects in conditions close to origination of ball lightning in nature, in Russian. So this is all translation from, that's why it's not, some of it's not translated very well.
A little bit rough,
the experiments on flowing of high power pulse of current in distilled water have been executed in the works. Class of long-living luminous objects, LLO, which temperature is in the range of 102 to 103 Kelvin, has been discovered. The estimations density, heat diffusivity, excuse me, heat diffusivity, glow power, and density of particles in long-living luminous objects have been made. The values obtained contradict to known data about oxygen-hydrogen, oxyhydrogen associations. The hypothesis that LLO discovered in aerogel has been suggested. It explains the most of experimental rated data about properties of luminous objects. However, the question of nature of aerogel substance remains an open question. Okay,
Excuse
so
me.
that's that.
Yeah. So what's really interesting is what Brian brought up, the fact that these structures, as you spin them up and make them bigger, they become more stable. That's fantastic information. And does anyone else have any comments before we stop the recording about everything? And I do want to thank again Chris Beskar for giving us this Ken Shoulders information, and definitely John Hutchinson for being live the other night, and Bob Grenier and Rob Harris and everyone involved with what happened the other night. This is fantastic. Yeah.
Okay, shall I stop it? You ready?
Yeah. Yep.
Stop it. So let's just